Ja, hallo alle zusammen. Es kann ein bisschen auf Deutsch sprechen. Ja, wir haben eigentlich die Testchecks beim Deutsch gemacht. Ja, deshalb hallo zusammen. Willkommen zu dieser Session, auf dieser Session mit dem neuesten cooles Features auf Helidon. Ja, vielen Dank für Henrik. Eine sehr tolle Session auch gemacht. So, danke sehr. Okay, now I'll switch to English because this session is declared as English. And let us actually dive into the newest and coolest features of Helidon. So if you probably have joined my session previously earlier this day about Helidon and Kotlin, I already done some introduction who I am. So once again, my name is Dmitry. I work for Oracle and I work on Project Helidon. So we're really short of time. I mean, 15 minutes. I'll try to do my best to show you everything. That's why I have to speak really fast, and I hope you will enjoy, because you see the agenda is really, really awesome because we have a lot of cool new features which we'll explore one by one. So, but before then, just a small reminder what actually Helidon is. Helidon is a small set of libraries for developing microservices, named after the wonderful bird swallow, which very nicely represents it. So Helidon means swallow in Greek language. So it is open source. So we are accepting PRs, and we really hope that you actually show us and contribute us your code. It's reactive, it's built on top of Netty, it's cloud native ready. You got everything out of the box to run in the clouds, and wonderful Graphium native image support. So it's really tiny. What does it mean? That the memory footprint is really, really, really small. So the startup time is really minimalistic, I would say. So fractions of second. And just to remind you once again, so Helidon is once again built on top of Netty. So this is a brief overview of the architecture. So it's Netty. Then we have a layer of reactive stuff, actually wrapping it up and creating all this wonderful reactive stuff for serving your, so for actually working with or for creating your microservices, and actually also showing all the required metrics, health checks, making it fault tolerant, etc. It's written pure Java in reactive way. And as we say, one of our main goals is actually to make it portable in terms of specifications, so micro profile. So we have an overall layer, which is like a Helidon MP, which makes it fully compatible with a micro profile, which means that you can easily port your code to Helidon. So your micro profile compliant code. Let us have a look. So once again, we have this 13, I guess, there's specifications, which are the core. We all support them. We all support it on up to this version, as far as I see. This is how it looks in Helidon. So you not only have this 13 specification, actually out of the box you got even more stuff. So you got everything which is like micro profile specific. You got additional specifications which are not like the core stuff of a micro profile, like GraphQL here. Also got them out of the box. You get Jakarta E specific stuff, including persistence, including like WebSocket. Once again, not part of your micro profile, but you still got them out of the box. And you get even more because we have high demand. So this is the course in gRPC. Let me see. Also have the out of box. You just go there and install it, then you use it. So you have course, you have both gRPC server and client. And as I said, instead of hiding all this wonderful wiring over Netty to create your microservices, we decided to show it to you because it's very nicely, beautifully made. So the APIs itself are really good. And we called it Helidon SE. And why I'm showing in this very strange frame, because we call it internally the danger zone. That means that you get the maximum power. So instead of hiding this power tools, we open this power tools to you. And as you see, technically get everything from microprofile world, and even more. So you get reactive web client, which is specifically made to make everything reactive, since we are planning to do everything reactive, actually do everything reactive. And you have a DB client, which is also totally asynchronous and really small, just with the idea that you are you are able to communicate with a database in asynchronous, reactive way. So this is a very cool stuff. So it just runs your DB, actually synchronous driver inside a different executor and provides you a way to talk with it asynchronously. So you see here, the footprint is really small. So if you compare it to the MP, so we just removed all of the magic, and it's pure Java, and so that's why memory footprints are just tiny. And the startup time, because if you don't have all this reflection happening there, so it's just minimal. It's all fractions of a second. So that was really small introduction. Once again, I hope you visited my previous talk about colonizing Helidon, so there is a bigger discussion. And once again, I kindly encourage you just to Google Helidon introduction. There is a wonderful, wonderful talk which we made together with MicroStream guys about it. So there we have a 1 hour full big introduction about what Helidon is. But since the talk itself is called What's New, let us actually explore what new we have. So we have some cool new features, and cool new feature number one actually is, once again, Oracle specific, because you see, we decided to make a very, very good connection to Oracle Cloud Infrastructure. And as you know, Oracle Cloud, so it's very, very big. It's one of the first big platforms that provide everything. So infrastructure as a service, platform as a service, software as a service, even data as a service solution. So we get everything there. And we support practically everything in the world. And I believe so many people actually use it. And that's why our connection to Oracle, since we are technically like, so Helidon is actually run by Oracle. Helidon project, although it's open source. Strong connection to Oracle Cloud Services is really cool. And we decided to create our own custom-made components there. Because there are a lot of services, we decided, so we talked to our customers what would be the best thing to them. And currently we're developing a lot of them, but there's three, which is OCI Vault, OCI Object Storage, and the telemetry are included. They're custom made. That's why they don't depend on any other libraries, which is extremely important. That means that no third parties, really only our stuff. So it will be easier for you managers to choose what to do. And why Helidon is a good solution, because we don't have any transient dependencies that you don't need. As you see, so just a small demo. It will be just for both. So you go to Oracle Cloud, for example. We will take the object storage because we don't have time to explore each of them. So we'll just take object store. So as you see, you have this Oracle Cloud when you have some description what it is, and a really small demo like how can you use object storage in MP. So there is just an object storage option which you just inject, and you just will be able just to get the objects really easy. So you just create a request. So there's a builder for it, and just specify the bucket and the object name, and you're done. So you're able to access it. The same is easily done in Helidon SE. So Helidon SE has actually the one who works with Helidon, they know that it's a pure Java implementation. That's why we use pure Java stuff. Once again, there is an object storage class, which like a support object comes to you. There is a builder for that. You just specify the bucket and specify the name, and it does everything for you. Once again, it's our custom implementation, and it's really cool because once again, no other dependencies happening somewhere outside, and that's why it's really clean and very fast. So about all of these features, there's a perfect, I would say, article by the guy who designed them and actually implemented it, our architect, Thomas Lange. He created a good article, so I highly encourage you to read it on our official Medium blog. And there you have the examples, and you can play with it. So cool feature number 2 is Neo4j support. So we are now coming with out-of-the-box Neo4j support. I probably think that everybody knows what Neo4j is. You know, it's a graph database management system. By Neo4j is a de facto standard for graph databases. So whenever you have a graph database, it's highly likely, I like this combination, highly likely, that it is Neo4j because it's the best solution available on the market. We decided that supporting it out of the boxes will be valuable for our customers. By the way, we have a lot of customers using exactly this combination of Helidon and Neo4j, especially in fraud detection systems, etc. And we decided that having it out of the box will be just awesome. As you see, Neo4j is implemented in Java, so it's easy to use it directly out of this code. And there's a cipher language we can use. So what actually is the support for now? The support is really awesome because you just specify in the properties of your microprofile config or your application YAML file what is the connection information, and you got it. And then actually Helidon configures everything for you, creates the driver for you, and you could only just inject it in the code. And in terms of SE, you can also build metrics and you can build health support. So this comes out of the box for MP. For Helidon SE, as you have all the power in the world, you have to do this manually, and you actually can use it. So I can even show you a small demo how to use it. So first of all, we have created a small database. So this is the movies database that you have as a typical example, I would say, of using Helidon, not Helidon, but Neo4j. And this is a wonderful visualization done. So let us see how we can use it. So it's currently running in the Docker image. So what is cool about it is that actually all of this is set in examples in our official repo. So I'm just going to show you the examples, and we can play with them directly from our repo. So as you see, there's a movie database. We just go there and we share it as a resource. So we have created like a movie repo, and this movie repo, just with some cipher, as you see, we're using modern Java, or JavaScript, but you still want ours. It just accesses this as we got the driver, and we can use it. So we just create we just have, I would say, getter method to get all the movies. So if we just run it, I guess target and Helidon Neo4j example. Well, without zoom, it starts for less than a second, but you see it really does start very fast. And it says that there is an integration for that. We just do curl, and we can get all the movies. So it's movies, and yes, you can see. So the integration is really easy. So we just get the movies, and voila! I would say the same can be done in Helidon SE, and we don't have time to show it. What is the cool thing about it is that we have health checks, and we can even from the health check, we can see that Neo4j connection is up and running. So metrics and check, everything will be gathered for you. So we get really strong support for that. And I'm really happy about it. Special thanks to Michael Simonis, if you're watching this. He made a lot for this to happen. So this is a cool feature out-of-box support of Neo4j, both for Helidon MP and Helidon SE. And now we are able to move to next cool feature. Next cool feature is long-running actions. Yes, this is something my colleague, good friend of mine, Daniel Catch, has been working really hard, and I'm really honored to be able to show it to you. So Microsoft Profile Array. So what is it? It's actually, as we're working in distributed systems, everything, all the microservices are running in a distributed world. MicroProfile, sorry, provides a very nice specification to work on distributed transactions. And it's based on Saga pattern, so quite famous pattern, used to actually, it's invented back in, I guess, 70s, correct me if I'm wrong. And it relaxes some constraints of ACID transactions, but it really provides a good tooling for that. So currently Helidon uses Narayana as a coordinator. So why I'm saying coordinator, later on I will show you why. But we are also having our own, so thanks again, Daniel, implementation of this coordinator, and I will show it in my demo. So what is the main idea? So two main components are involved for LRA. So actually the participants are just the microservices themselves, which will be involved. So imagine you have so logically transaction running through multiple services. For example, I want to book a treat. That means that you first call a microservice for booking your airline ticket. Then you call a microservice for booking your hotel ticket. Then you call microservice to actually do the payments for this, all of that stuff. And it's only not semantically, transactionally completed only if the ticket for a aircraft is bought, the hotel is booked, then it's paid, then it's logically completed. And here is a good example of LRA. So it gets participants, which is like microservices that you use for that. And there is a coordinator. So there's a separate service, like an overall service, LRA coordinator, which actually takes care and sees, okay, so we have this service called, it's completed or it's not completed, and it coordinates all the activities, and it's actually said, okay, the full action is complete or the full action is not complete. And actually what it happens, so you start LRA, you add some operations for that. So this is the diagram describing it. And whenever something goes wrong, you should be able to compensate this action. So that's why for microprofile LRAs, practically quite a new specification. I guess it's really fresh. So there are several annotations created. So first of all, you declare something which is under LRA with LRA annotation. Then you have a method for calling for compensation, something that indicates the completion of the action. You can just leave and you can forget everything about it. And of course, you can call the status. So are we in a transaction or are we out of transaction? And let us actually have a look at it. So the demo itself, what's cool about it, it's already available to you on our GitHub in the examples section. So you will be able to just play with it. With this example, Let me just open the right actually. So there is the examples and L array. Let us see the service itself. So there is an example application. So we say, okay, so there is an L array for starting the example. There is a L array annotation for something is completed. And for example, we want to say, okay, so if we got a failure, we need a compensation method. And so we just declare as a compensation method. And let me run it. By the way, here, I want to make it with our own coordinator. So there is an L array coordinator here. What's cool about it, it's pure Java. So I just run it, this main method. You can also access it in the Docker as a Docker image. So if we actually play with it, so once again, I'm sorry, but Zoom usually takes really a lot of the resources. So whenever I do a live demo, it's really a little bit slower as it should be, although this machine is quite powerful. But I'm sorry, but sometimes it starts a little bit slower. Okay, so the L array coordinator is already running. So if we take a look at the README, you can run an declare a coordinator on this board. So you can just run our own coordinator or an Ariana coordinator. So they're both available with Docker images. And you see, as it's running, let us actually run it. So I just need a terminal to open it. So let us just go to the project and run our service. So I will just go java -jar. So I already precompiled everything for you because in the interest of time. So we will just start the example and we will try to call these methods and see what actually happens there. So yes. So first of all, let us do some start examples. Just curl. So we see it's the L array coordinator is running. The coordinator is running. Our Helidon using L array is running. So I will just do the curl. And so we will see nothing happens for us, but it does happen for the coordinator. And you see, so we started the example, it declared as action, as completed, so everything is okay. And I guess there's also, no, not at this point. Now let us do something wrong. I mean, let us provoke some compensation action. So there's a special method with a boom, which is like a bad value for us, to run it, and an exception will suddenly appear. So we won't feel it as a client, but here you see we declared an exception. And as you see, the compensation action is called. So that means that our L array coordinator has just declared that for this L array operation, like for this ID, that was a compensated action, and you can see that the transaction actually failed, and the compensation action was called. So compensate. So L array ID is compensated, and as we see this in our result. So we now fully support the spec, all the TCKs, everything is perfect here. So it's already checked in, and whenever you need L array, you just use it because it's there and it's out of the box, and it is running. So you can use both our L array coordinator, which is like still declared as experimental. What experimental means that some APIs may change, but it's fairly stable. It's really good, and you can also use it with different coordinator, which in our case is Narayana coordinator, and it's up to you what to choose. So I guess both of them are running really, really nicely. So I will just terminate. So because the ports, we need the ports, and good. Once again, everything is available in the examples. You just come and play with it. Nice. Let us move to cool feature number 4. And it is something which I love very much. This is the support of RSocket. So I'll be a little bit like, it's not exactly unpolite, but unhumble. Is that I was the one really implementing it, so I'm really proud and happy that this will actually come in the nearest release, I'd say. It is already approved. Some non-bureaucracy, I would say, but some activities have to be done to become part of the next release. But it's already there. It's still experimental, but actually, let's have a look. What is it? RSocket and why it's so important for us. So probably many of you have seen wonderful talks of Oleg Dokuka about it. I'll try to be short here. So RSocket is a binary point-to-point protocol, and it's following the reactive paradigm itself. So it's following the reactive stream semantics. It's a really, really good alternative to HTTP, and it's really designed for distributed systems, which Microservices actually is part of. Really focused on performance. So what is cool about it is that you are not bound to a specific protocol to actually have a choice of protocols. It can be a pure TCP protocol if you want it. So it can be WebSocket, which is a good alternative. It can be Iron, and it can be even HTTP to streams. So actually, its frames, the RSocket frames, are transmitted to over these protocols, but once again, they are really small. Once again, what are the coolest semantics about it is that actually you have different ways to talk between client and server. So unlike HTTP, which is quite ancient, let's be honest, and TCP, which is quite low level, actually. So here we have the guys have defined 4 ways of communication. So first one is fire and forget. So you just send something and you don't care whether it'll come or not. Request response, which is like we get requested something and you are waiting for the response. Of course, you can request something and it will give you back a stream. For example, give me that movie on Netflix and start streaming you data. Or you can do it actually as a channel. That means that you stream a lot of stuff to the server and it streams you back a lot of stuff. Really cool duplex protocol. And you got this in protocol description. And actually, how can you use it in Helidon SE? In Helidon itself, so not only Helidon FB and Helidon SE. So we have thought a lot. So when we have decided that we can actually implement our own set of annotations for RSocket, for Helidon MP. That means that it's not yet stabilized, I would say, because we need some feedback from you users, whether you find it good or not. But we have decided that binding it to messaging, like it was done in Spring, is really cool. But in our case, having our own set of annotations for RSocket makes it really, really pure and clean. So that's why we have created this RSocket, which we decide, okay, where is the endpoint? And we have defined annotations like fire and forget method, request response, request streams, and request channel. As you see, you are able to use it with, because it's reactive, you can able to use it with completable future, or you can use it with our own implementation of global flow with singles and multis. So currently it makes a pure Java way with completable future. So we are actually bound to the level of payload. So that means that you are responsible for mapping your objects with a payload. Maybe as a second iteration of usage of the protocol, we will create automatic mappers for that. But you see, we want to keep it really give you the full control, because the way you wrap your payload can be really different, because some of the implementation, as far as I know, I just translating everything to JSON and just send it, which is a little bit, I would say, how you say, ineffective if you are working with binary data, because RSocket is binary protocol. So you are care for a payload, and this is a set of annotations which you can use. For Helidon SE, for those of you who are familiar with the idea of Helidon SE services and routing, so we have created following absolutely the same semantics, the RSocket routing and RSocket services. So the only thing you have done is actually to implement a service, which you also have like 4 different rules. Like, what will you do if you receive fire and forget? What will you do if you receive a request, etc., etc. So once again, it was really big work done. It's RSocket set of annotations, and it's our own routing solution for 3 different methods. Okay, let us jump to the code as well and see how it works. So let me just move something out of here, because I don't see the screen. Yes, now it's much better. Okay, let us close the resources we don't need, and we can go to RSocket. So once again, we provide both client and server. So we have everything once again. And let us actually start one server when we have, there's a greeting resource, and we will have an RSocket resource. So once again, as you see, we have an RSocket service. It's annotated under this path. And there is a method, by the way, here, you can see I'm using our own implementation of reactive, so singles. Here we have another service, which usually uses is completable future. So it's up to you what you want. Completable future is enough, but if you want to make it more reactive somewhere in your code, we still provide you services for that. So, and if we actually run this stuff, yes, so it will just start. It's precompiled for you. So I just run it. So once again, I'm doing examples with Helidon MP, but it can be done with Helidon SE as well. It's fully the same functionality. It's really starts faster, but let's see it here. So we get target and examples here. Once again, because of Zoom transmission I'm doing right now, captures screen, captures camera, but still this was very fast as a start. It's a little bit slower than usual. In your machine, it will be fractions of a second. Once again, you see we have this RSocket support. It's now running a server. And let us send some frames. So here I have created some request response. Currently, it's set up to use web service as a transport. So in your properties file, you just specify. We are now limited to web service or to WebSocket because we want to establish the APIs, and we want to establish both for Helidon and MP and SE. What is actually, once again, cool about it is that our implementation does not, unlike other implementations, like in other frameworks, we do not start a separate native server to serve your RSocket stuff on a different port. Currently, this thing runs on one port, and it runs on our own netc. I would say it like this. That means that as it runs on our own METI, no other ports are used. So we just run web service, and it should work. So let us see. So for example, we are sending a frame. You see, I got some debugging information. Let me make it a little bit more. So you see, I said, okay, so we have metadata. So we use a print root and we say hello RSocket. This is how it looks. And then we have a data which is received, which is backfire. Why hello? So we get backfire because we actually coded like this. So if we go to service, this is the print root, okay, for this fire and forget for request response. Yes, we just received something. In our case, it will be this one. Yes, received a payload, and we say, okay, send him back a backfire, and it's done like a single, so it's done in an asynchronous way. You see, it works. So another option is to use RSC fire and forget. So you see, we just send fire and forget message, and you see we got this payload, and actually the client itself is not aware is a response, is it got there or not. It's super effective, and it still works. Once again, just annotate your stuff, and you will be able to use it. Once again, we are now limited to WebSocket, but will come quite soon the other support. But now I just want to stabilize the APIs and see if it works okay. And back to slides. So cool new feature, RSocket. Next cool feature is Micrometer Support. So Tim Quinn, our great team member, was really playing with this, and I created this wonderful instrumentation for SAID. Currently really supported by everybody. And what is cool about it, that you just add one dependency, and you will be able to get your micrometer both in MP. So in MP, it's very easy because you use standard annotations, like for example, times or counter. So this is just an example. Or in SE world, you get their special Micrometer Support object, where you just declare, okay, so we want to get a timer for this, or we want to get a counter for something else. You just support it, and it provides you on the micrometer micrometer endpoint. It provides you everything you need. So in environments which use micrometer for to gather other information for telemetry, I would say information, it becomes available. So it's a really cool new feature, and it's I think it's quite highly appreciated by the customers that we have. And cool feature number 6, and this is one of the coolest, newest, freshest, amazing features that we have in Helidon. And this feature is microstream support. Yes, I believe in this conference is especially appreciated, and I really love it myself, because what is microstream? A really, I would say, revolutionary high-performance Java native persistence. That means that you can store any object, object graph or its subgraph, without actually heavyweight JPIE, etc., etc. So it provides you a really awesome throughput with really minimal latencies. I think everybody earlier today saw an advertisement that is even eco-friendly, I would say, because it saves like 89% of power used to talk to your database, like, all this serialization, deserialization, mapping, unmapping, wrapping, saving it, changing the model from object to relational and then putting it back. It really just gets rid of it, and you're able to use it directly, natively. And how actually can you use it? Once again, it's just a small example for this. So you got a annotation, special annotation, which is like MicroStream storage, which provides you a storage manager. And the storage manager, you just act in your usual way of acting with a MicroStream implementation. You just use it as a storage, and it works. So for Helidon SE is quite the same idea. So there is quite a context which provides the embedded storage manager builder, and this builder provides you just gets the configuration out of the micro profile or application YAML configuration. What is good about it is, as I said, so you just have one configuration point and you just use it, and you put your MicroStream configuration there, and Helidon cares to get this information to supply it to storage manager builder, and it will actually build you the storage manager, the storage itself, and you are able to use it. So I guess the best option is here just to show you how it works. So let me remove stuff I don't need. Let's close. So I don't have any ports here. So you see today many demos. That means that a lot of ports may be, yeah, just close all tabs. And we will switch to another example. And this another example is in integrations package. And here you see, here's a Micrometer Support, by the way, if you want to play with it. So there are a bunch of examples here. And we just go to MicroStream. And once again, in this case, we will use MP implementation. We just need it here. And what do we have? So there is Java, there's a greeting provided. So we use typical greeting application that we are usually using, like for demonstration purposes. So there is a resource for that. So it's really, I think the only thing we actually changed here is that we have created this storage, and unlike other services, we are storing all of our greetings. So every time you run it, your application again, it won't lose its greetings. So let us actually run it and see. So target Helidon. Once again, it runs. Maybe a little bit slower, but still fast, really fast. And you see we have MicroStream, currently still experimental feature, subject to change, but it's already there and you already can use it. And let us use README to, first of all, get some curls. So the easiest one is to send the greeting. So we'll use it's 7.7001, and we will say greet. It's hello world. We will say JCON. Hello JCON. And now we will make another greeting like howdy. Howdy. And every time we do this here, is that when we call it, so it will just use the new greeting. Yes, wonderful. So it's persisted the hello and howdy, and chooses it there. But what is the coolest part here? So for example, we close this application, and we start again. And if we do this with the regular example, it will just forget about howdy. But if we use it again, you see it connects back. It's from persistence that we have done and just gets this greeting out of it. Let us actually see what happening here. There's greeting storage he created for us, and it's extremely fast. And you got this integration, and this integration is like full integration. That means it's not only configuration that you read, but you are actually able to have a special annotation for that. like what is a microstream storage, how it gets configured, and actually CD extension for that. And the same is for SE, but pure Java. So as you probably see, this integration is really cool and it's really seamless, and you get this extremely powerful tool to persist your Java-specific data in the, I believe, most efficient way. So you see, it did work. Nice. So basically, these are the main features, but there is just a small bonus I have prepared for you, and it's test containers. So there will be a special article describing how to test Helidon, and I'm quite happy that Helidon works really good with test containers. There's another demo I have created for you, which is like, for example, we are able to wrap our Helidon in a generic container. I'm not working to make a specific Helidon container, but even for a generic container, it works perfectly. And so you can black box test your Helidon inside a Docker container with what is it? Test containers. So you can just do it with this, and you can do it other way around. So for example, for messaging, we say that we have to override some values here, and we are able to start a different container running a Kafka and test against this Kafka running inside of a container. It's really easily done with our Helidon test, and we just say that configuration, we can just override it and run it. Let's just try. We have another few minutes here. I think there is a chat questions. Chat question. Yep. Just 5 minutes. I really want it to be quick. So it just runs everything. Yes. We now have Docker running. That means that here we run our Kafka container inside of Docker, and it usually tests against it. For example, it sends some message and someone received some message, and you see, testing Helidon against Kafka is really cool. Yes, there's some messages here. So we are able to start Kafka, get the message, send the message. We tested the incoming and outgoing channel, and it's working perfectly. So just stop it, and we can use our Cucumber test as well, or we can use, as you see, just a regular test running inside of a container. So the article will come quite soon, and as a result, you actually can play with it. Just wait for the article. It's a little bit like inside what's coming next. So as you probably see, a lot of new stuff came in Helidon, and this stuff is really valuable, I would say, because it's not only a small framework now, it has really cool integrations, and you're able to use them once again out of the box. And I sincerely hope that you liked it, and there's more stuff to come. And probably this is it from my side. So, Dankeschön. Es war sehr schön hier zu sein. Thank you so much. So whenever you have any questions or have a think about it, just go to my Twitter, and then you will have it. So I hope you really enjoyed it. I see claps. Thank you so much. It's been a great pleasure. Bye-bye.